Welcome to ClickMyProject.com. Now I'm going to discuss about a lightweight mitigation technique against a modified version number attack in IoT networks. First, I'm going to discuss about the overview of the project. In this project, focused on detecting and classifying network attacks using advanced machine learning techniques. We start with a real-world data set that contains network traffic records labeled as normal or attack. The data undergoes careful pre-processing to handling missing values and address the issue of class imbalance, which is common in cybersecurity dataset. To improve model performance, we apply SMOT, the synthetic minority oversampling techniques, which generate synthetic samples for the minority classes, helping the balance the data set effectively. We then train two powerful machine learning models. The one is XGBoost, which is a gradient boosting decision tree algorithm, and the next is passive aggressive classifier on online learning algorithm suitable for large scale problems. And to evaluate these models, we use accuracy metrics, detailed classification reports, and ROC curves that visualize the trade-off between true or false positive rates. Among the two models, XGBoost showed strong feature importance and achieved high accuracy in detecting network attacks. For practical use, both trained models are saved so they can be loaded later for live prediction based on user inputs. Finally, the project includes several data visualized such as heat maps, histograms, and confusion matrix, which provide deeper insights into the data and model performance. This is our abstract. This is our workflow diagram. First, we need to collect the data set from Kaggle and carry out to the pre-processing step, handling the missing values, and carry out to the data splitting. The whole data set split, train and test, training for the train the model, and the test purposes performance of the model, and the carry out to the SMOT. I used balancing the data and carry out to the classification. I used two model, XGBoost and a passive aggressive model, and carry to the performance metrics. I evaluate the accuracy, precision, recall, and F1 score, and finally prediction. The trained model are used to predict the and classifying either attack or normal. This is our workflow diagram. Now see our demo of our project. This is the register page of the project. The user needs to enter the username, password. All fields are required and checked before submission. After successfully registered, the data is stored in a database. And then already the user registered page, directly going to the login page. Check the username and password. This helps the system secure and prevents unauthorized access. Click login, directly going to the workflow page. First we need to collect the data set. Click browse file. select our data set, open, display the sample data or data sets are displayed, and then next is pre-processing, handling missing values. Check the missing values. Three attributes fields are occurred in missing values, and replace after missing values. Replace the missing values are displayed, and then next is data splitting, and, and next step is smooth, balancing the data. Display the before smooth I used. Display the data splitting, training data and testing data. After smooth used, display the labels and count. And the next is classification. I used two model, XCBoost and passive recursive. Display the two model performance, evaluate the accuracy, precision, recall and F1 score displays in the classification report, and display the confusion matrix and the ROC curve comparison graph. And this is the another model, passive aggressive classifier performance models are displayed. Displayed accuracy, precision, recall, F1 score, display the classification result. And then finally prediction. Click prediction. This is the prediction page. The user needs to enter the attribute of the dataset. Click version number and click packet delivery ratio, and click latency and click energy consumption, and the next is a network overheated, and the next is retransmission count, and the next is CPU usage, and then next is memory usage, and next is routing table size, and the next is control message rate, and the next is neighbor count, and the next is subnet partition, and the next is root rebuild count, and the next is average hop count, and the final is signal strength, and finally click predict. Prediction result are displayed. Display the XCBoost model prediction. Display the DOS attack and with the confidence score, and the next is passive aggressive models are used. Display the prediction of attack, and why is attack is occurred in or displayed, and recovery tips are also given. This is our project. Thank you.